Master Plumber Licensure Exam. Fire Protection. Overview. Fire. It is a complex set of chemical reactions in which fuel combines with oxygen and an ignition source to produce heat, the fire triangle. Three elements, fuel, oxygen, and heat, are required to start a fire. The oxidation process will not be possible without any one of these elements. 4 stages of fire development. First, incipient. This first stage begins when heat, oxygen, and a fuel source combine and have a chemical reaction resulting in fire. This is also known as ignition and is usually represented by a very small fire, which often and hopefully goes out on its own before the following stages are reached. Second, growth. The growth stage is where the structure's fire load and oxygen are used as fuel for the fire. Flashover is not a stage of development, but simply a rapid transition between the growth and fully developed stages. Third, fully developed. When the growth stage has reached its maximum and all combustible materials have been ignited, a fire is considered fully developed. Fourth, decay. Usually the longest stage of a fire, the decay stage is characterized as a significant decrease in oxygen or fuel, putting an end to the fire. Flashpoint of a liquid. The lowest temperature a liquid at which sufficient vapor is given off to form an ignitable mixture with air near the surface of the liquid or within the vessel used, as determined by appropriate laboratory test. Fire extinguishers shall be installed even if the property is equipped with automatic sprinklers, standpipe and hose, or other fixed protection equipment. Types of fire. Class A, ordinary combustibles, wood, paper, cloth, trash, and other ordinary materials. Class B, flammable liquids and gases, gasoline, oils, paint lacquer, and tar. Class C, electrical equipment, involving energized electrical equipment. Class D, combustible metals, such as sodium, magnesium, potassium, and other similar materials. Class K, combustible cooking media, vegetable or animal oils and fats. Rating of fire extinguishers. Class A, extinguishers will put out fires in ordinary combustibles such as wood and paper. The numerical rating for this class of fire extinguisher refers to the amount of water the fire extinguisher holds and the amount of fire it will extinguish. Class B, extinguishers should be used on fires involving flammable liquids, such as grease, gasoline, oil, etc. The numerical rating for this class of fire extinguisher states the approximate number of square feet of a flammable liquid fire that a non-expert person can expect to extinguish. Class C, extinguishers are suitable for use on electrically energized fires. This class of fire extinguishers does not have a numerical rating. The presence of the letter C indicates that the extinguishing agent is non-conductive. Class D, extinguishers are designed for use on flammable metals and are often specific for the type of metal in question. There is no picture designator for Class D extinguishers. These extinguishers generally have no rating, nor are they given a multi-purpose rating for use on other types of fires. Types of fire extinguishers. Dry chemical extinguishers are usually rated for multiple purpose use. They contain an extinguishing agent and use a compressed, non-flammable gas as a propellant. Halon extinguishers contain a gas that interrupts the chemical reaction that takes place when fuels burn. These types of extinguishers are often used to protect valuable electrical equipment, since them leave no residue to clean up. Halon extinguishers have a limited range, usually 1.2 to 1.8 meters. The initial application of halon should be made at the base of the fire, even after the flames have been extinguished. Carbon dioxide extinguishers are most effective on Class B and C liquids and electrical fires. Since the gas disperses quickly, these extinguishers are only effective from 1 to 2.4 feet. The carbon dioxide is stored as a compressed liquid in the extinguisher. As it expands, it cools the surrounding air. The cooling will often cause ice to form around the horn where the gas is expelled from the extinguisher. Since the fire could reignite, continue to apply the agent even after the fire appears to be out. Definition of terms: automatic fire suppression system. An integrated system of underground or overhead piping, or both, connected to a source of extinguishing agent or medium, and designed in accordance with fire protection engineering standards, which, when actuated by its automatic detecting device, suppresses fires within the area protected. Sprinkler system. An integrated network of hydraulically designed piping system installed in a building, structure or area with outlets arranged in a systematic pattern, which automatically discharges water when activated by heat or combustion products from a fire. Fire sprinkler. A fire sprinkler controls the flow of water to a fire. Fire sprinklers are a type of valve that, when exposed for a sufficient time to a temperature at or above the temperature rating of the heat-sensitive element, glass bulb, or fusible link, releases, allowing water to flow from only the affected sprinkler. Concealed sprinkler. A recessed sprinkler with cover plate. Flush sprinkler. A sprinkler in which all or part of the body, including the shank thread, is mounted above the lower plane of the ceiling. Pendant sprinkler. A sprinkler designed to be installed in such a way that the water stream is directed downward against the deflector. Recessed sprinkler. A sprinkler in which all or part of the body, other than the shank thread, is mounted within a recessed housing. Sidewall sprinkler. A sprinkler having special deflectors that are designed to discharge most of the water away from the nearby wall in a pattern resembling 1/4 of a sphere, with a small portion of the discharge directed at the wall behind the sprinkler. Upright sprinkler. A sprinkler designed to be installed in such a way that the water spray is directed upwards against the deflector. Wet piping sprinkler system. Automatic sprinklers are attached to a piping system containing water that discharges immediately from sprinklers opened by a fire. This is the type commonly used in the Philippines due to its relatively simple design and rapid response, 98% reliable. Dry piping sprinkler system. Dry valves allow pressurized air in the water lines to hold water back until a sprinkler head opens. Appropriate for use in unheated, low-hazard occupancies. Dry standpipe. A type of standpipe system in which the pipes are normally not filled with water. Water is introduced into the system through fire service connection when needed. Wet standpipe. It is an auxiliary fire line system with a constant water supply installed primarily for emergency use by the occupants of the building. Combination standpipe. A pipeline system filled with water and connected to a constant water supply for the use of the BFP and the occupants of the building, solely for the suppression purposes. System pipe network. A sprinkler system is a series of pipes progressively decreasing size from the water supply to each of the most remote fire sprinklers. Stop valve. A stop valve, also known as a gate valve or isolating valve, is used to isolate the flow of water into a fire sprinkler system. Stop valves are multi-turn valves, opened by a hand wheel or other operating device, generally open in a clockwise direction and closed counterclockwise. Valve monitor. Valve monitor is used to monitor the state open or closed of the stop valve. The water within an automatic fire sprinkler system can be divided into two parts. First, water supply or mains. Second, installation. Alarm or check valve. The alarm valve is used to control the flow of water into the fire sprinkler system. This is accomplished by providing a one-way valve that is normally closed when the water pressure on the fire sprinkler side of the valve exceeds the water supply pressure. When the pressure equalizes or falls below the water supply pressure, the valve opens to enable water flow. Motorized alarm bell or gong. The motorized alarm bell or gong is a mechanical device operated by the flow of water oscillating a hammer that strikes a gong, causing an audible alarm signal. Pressure switch. The pressure switch is an electromechanical device that monitors a fire sprinkler system for a fall in water pressure after the alarm valve. The purpose of monitoring a fall in pressure is to activate a switch that is monitored by a fire alarm panel or alarm signaling equipment as the primary method for signaling an alarm to the fire brigade. Flow switch. The flow switch is an electromechanical device that monitors the flow of water through a section of pipe within an automatic fire sprinkler system. Flow switches are often fitted with a mechanical delay, up to 6 minutes, preventing small or minor water flow fluctuations from signaling an alarm. When sustained water flow is detected by a flow switch, a signal is transmitted to a fire indicator panel. This signal is then used to determine which section floor of a fire sprinkler system has water flow. Pressure gauge. A pressure gauge is a mechanical device that is usually fitted to an automatic fire sprinkler system. There are usually two gauges fitted to a system, one showing the water supply pressure and the second showing the installation pressure. Normally, the pressure differential should be not less than 200 kPa. Fire pump. Fire pump is a device that provides the required water flow and pressure for a fire protection system. The fire pump unit itself consists of a pump, a driver coupling connecting the two, and a base plate. Jockey pump. A jockey pump, or a pressure maintenance pump, is a small apparatus that works in conjunction with a fire pump as part of a fire protection sprinkler system. A jockey pump is designed to keep the pressure elevated in a fire suppression system so that the main fire pump is prevented from running unless absolutely necessary. It consists of a motor, a pump, and a controller.